Hi guys, sorry I'm not there today. I'm feeling quite lovely, we'll just call it. So I figured we would just keep advancing with the material. I know we went over 2 chi-square examples in class, but I figured I would just give you the third one. Yeah, lovely hand video. I figured I'd give you the third one through a video, so that way we're not falling too far behind. So in this example, guys, and this is on my website, so you can just grab it off of there because I'm going to be flipping through the pages. So the data is all on my website, but you are setting tail length in squirrels and perform the standard genetic crosses. From the following observations, determine how this trait is inherited, which allele is dominant, and is the trait autosomal dominant, sex linked, etc. So the etc. would be, the codominance, incomplete dominant. Assume the parents are true breeding and test your hypothesis with a chi-square. So here's what we're going to do for this one, guys. Here's our data. We have been given already what type of inheritance the trait is passed on from generation to generation by, but this one it's not, so it involves a little bit more thinking. We have the parents here, and then in the F1 generation we have 145 long-tailed males and 155 short-tailed females. So after they mated their offspring, which is the F2 generation, we have 73 long-tailed females, 77 short-tailed females, 72 long-tailed males, and 78 short-tailed males. All right, let's kind of recall what all these different types of inheritance mean. If we have incomplete dominance, remember the heterozygous, so like big or little r, it's going to be a blend of the two. If it's incomplete dominance, all right, it'd be like a long short tail guy. It doesn't really make sense because there's no third phenotype here, so we can rule that one out. Also with codominance, remember the heterozygous it shows both of them. Well, you can't really show a long tail and a short tail in one. That doesn't make much sense. So we can rule those two out already. We can't rule out regular complete dominance, and we can't rule out sex linked yet. So those are the two we kind of have to test. Let's try to eliminate some things off the bat. We know that if this was regular dominance, we should always have that 3-to-1 ratio. All right, but that's with 2 heterozygous individuals. So for this one, what we have to do first is kind of determine, okay, what's going on with the traits, with the long tails and the short tails. So what I'm going to do here, guys, is I'm just going to try sex linked to start off and just see if it works. So we have short-tailed females and we have long-tailed males. We know the females are going to be XX, and we know that the X's carry 99% of the traits, and the Y's don't really carry the traits. So the male's going to be XY. Right? Now, I didn't add any alleles here yet, but we know that normally we're going to have our even distribution, 50% to 50% of males to females right there. Now, we know that this female has to have a short tail, and we know that the male has to have a long tail, all right? And then if we look at the offspring, we see that 72 long-tailed males and 78 short-tailed, there's also 78 short-tailed males. So this would mean, since we have both of them, that the mom, because she's the one giving the boys a X allele, we know that she would have to be heterozygous, all right? But let's look at the females. We have pretty much an even distribution there as well. So I'm just going to pretend that, let's say short-tailed is dominant, and we'll see if that works out. I'm going to use big T to represent that. We already said that the female has to be heterozygous, so carry these alleles down here, and there we go. All right, and And we know that the male was long-tailed, so we're saying that's a little t. And if you notice here, we get all 4 of our genotypes for our F2 generation. We get our short-tailed females, we get our long-tailed females, we get our short-tailed males, and we get our long-tailed males. So this would work. Let's try it the other way. Let's pretend that long-tails is dominant. Okay? So the female, if long-tails, so this over here is short-tails dominant. This over here will be long-tails. So if we have the long-tails dominant, the female is still going to be heterozygous, but now the T is going to be for long-tails, not short-tails. Okay? So that's still the same heterozygous genotype, but for this one, the male, don't forget, has a long tail. We're saying long tail is dominant. So he'd be X big T, Y. Let's do the genotype. This one would be X big T, X big T. This one would be X big T, X little t. This one would be X big T, Y. And this one would be X little t, Y. Males are still good. In the males, we still get 2 different individuals, 2 different genotypes. This one would have long tails, this one would have short tails. But if you look at the females here, they both would be long tailed because they both have 1 big T. So we know that this one cannot be correct. All right, so we got to go with the other one if we're going to try sex linked and go with that. So we already solved the first part, guys, that short tails are dominant, and that was able to get us through the first part of the question. If we keep looking at this though, and take into account our F2 generation, notice here, guys, we almost have the same number of each one with long-tailed females, short-tailed females, long-tailed males, and short-tailed males, right? We almost have the same number. In other words, the same distribution. Over here, we have our four characters, the 2 male, the 2 female, all with a different trait, and it's always 1 to 4. So we have 1 female with short tails, we have 1 female with long tail, we have 1 male with a short tail, and then we have 1 male with a long tail. So it's 1 to 4. So in other words, each one is 25%. Well, that looks pretty darn good to me. So we're going to go with that one, guys. So I already set up our chi-square here with that. And let's put our observed down. For long-tailed females, we had 73. For short-tailed females, we had 77. For long-tailed males, we had 72. And then lastly, for short-tailed males, we had 78. All right. If we add those numbers up, 73 plus 77, okay, we should get an even 300. Okay. Now, to get the expected, what we're going to do is, since we have this number here, we have our total, and we know each one of these from our previous page here is going to be 25%. We're just going to take our 0.25 and times it by 300, and we get 75 for each one. Okay. Subtract, we get -2 there, +2, we get -3, and +3. Square all those numbers. When you square them, we get positives all the way down. And then we're just going to divide. So 4 divided by our expected. I got 0.053. Okay, both of those. And then 9 divided by 7.5, I got 0.12 and 0.12. Add all those together and we get 0.346. Okay. So in the end, guys, we have all of our data here, and our x squared value at the end was our 0.346, okay? Now we're going to put this into our chi-squared value paper that I gave you guys. That's the t-test also, that's the other word for it. And our degrees of freedom is always our number of phenotypes, 1, 2, 3, 4. We always subtract 1 from that. So we have 3 degrees of freedom, okay? If you look at, sorry, I'm looking at it on my computer here. If we look at our x squared value for that, you guys can see that that's definitely in the accepted range, our 0.346. So in conclusion to all this, we would accept, okay, that it is short tails are dominant, and we would also accept that this would be sex-linked, okay? And the reason we accept it that it's sex-linked is we got such a low value here. If we would have done the same thing, guys, with complete dominance, with only 2 phenotypes, we probably would have got a huge number here, and we would have been like, oh, crap, something's wrong there, because your number would be so high. All right, so this one, what we're doing is we're just determining what type of inheritance it is. I know this problem's a little tricky, guys. This is kind of the hardest one you'll ever have to do for chi-square stuff. But hopefully this helped, guys, and I'll see you next week. Have a good one.